Hello everyone, welcome to AI Anytime channel. So in today's video we are going to work on a very interesting problem. Now you have already seen a lot of image generation model, generative AI models that where you perform some kind of prompt and then you get an image as an output. We already have seen the way we can generate images based on prompt. Now just imagine if you want to generate prompt from an image. Now you have an AI generated image and now you want to understand what kind of prompt people have made previously to generate that image. Can we reverse engineer the entire process? Is there any way that we can reverse engineer stable diffusion, or is there any way we can reverse engineer Midjourney or DALI, for example? This is a problem that we are going to tackle today. We are going to explore if there is any way, if there is any possibility that we can do this reverse engineering on stable diffusion, for example. This is a challenge that we are going to work on, and we will use something called CLIP. Again, OpenAI to rescue. We are going to use CLIP, which is an acronym for contrastive language image pre-training. Okay, we are going to work with this model, and there have been a tool which has been built on top of this model. Now if you see on my screen, I have an image of Mona Lisa which I have generated with the help of stable diffusion. Okay, and there have been multiple prompts or the iteration, and the prompts base was ChatGPT. So I asked ChatGPT, and ChatGPT suggested me the prompt, and then I used that prompt to generate this image. Now I'll use this as a reference image. I can also use some of the other images that I have in my directory, and we are going to have a look at something called CLIP, which as I said, it's contrastive language image pre-training. So it's an efficient model that learns visual concepts from natural language supervision. It's a very interesting fact that CLIP has been developed by combining research on zero shot learning and natural language processing. Now if you're not familiar with what zero shot learning is, so basically zero shot is a technique that allows machine learning model to reorganize new objects without having to be trained on example of those objects. So CLIP has been trained with for that purpose basically. Okay, so it generalizes better on unseen objects, and it is very robust. Now if you come down, I'm currently on the OpenAI see on this website where I'm having a look at CLIP, okay, which says it's a neural network. Of course it is called CLIP, which efficiently learns visual concept from natural language supervision. It has this natural language supervision, that's how it learns. CLIP can be applied to any visual classification benchmark, and similar to the zero shot capabilities of GPT-2 and GPT-3. Now we are living in this world of zero shot learning. We have few shot, we have zero shot learning. This is why these models are being generalized better on vast variety of data that they have, or the data mediums. If you come down, it also has this benchmarking with Resonate 101 and CLIP VITL. Now what is VITL? It's an acronym for Vision Transformer. This is the language, this is the acronym for this. You have seen the benchmarking has been done over here, okay, on how CLIP has performed better on this ImageNet dataset, for example, or any other dataset that has been there. Okay, it says an accuracy on ImageNet test set. You can read this. If you come down, they also have this high level architecture. It's very fascinating to understand. They have separated this in 3 steps. The first, if you read, it says it pre-trains an image and text encoder here to predict which images were paired with which text. So the image pair with which text pair, and then they use a behavior to turn CLIP into a zero shot classifier. If you see it over here, it says they have this zero shot classifier over there, and it's very interesting to read this paper. They have a lot of benchmarking done on different data sets that you can have a look. They also have the advantages of CLIP, which is very robust. They also have a metric that it generalizes it better on unseen objects, and it has performed better. Okay, now based on this CLIP, there have been multiple tools which has been built later on, and one of the tool is called CLIP Interrogator, and this is what we are going to use for this purpose. We have this Mona Lisa image or any other AI generated images. We'll try to pass this AI generated images and we'll use this CLIP Interrogator tool. to work with. Now if I come back on this, I'll give this research paper link in the description. You can have a look at it. Now what I will do, I'll use Google Colab, for this task, where I will have an image as an input, and then I will try to generate the respective prompt, or that's basically a detected prompt. This is a prompt that is being detected or generated by the AI model, okay, or the tool that we are going to use, the CLIP Interrogator tool, which has been built on top of a CLIP model. Now just understand the use cases of this, right? This kind of solutions help in reproducing the image. Now you want to reproduce the image, the stable diffusion image that we have, or any other AI generated image. It can also help you reproducing it. Now it also help you as a response validator. Now we have been talking about prompt engineers. Can we also talk about response validator? The response we are getting, how are we going to validate those response? This is also an example, and it also help the end user or the companies or organization to detect AI generated image. Once you have the prompt, you can use some kind of rule based engine, or regular expressions, so that can be anything to detect some possibilities whether an image is being generated by AI or not. This is what we are going to do, guys. I will use Google Colab here. I'm just spinning up a notebook from Drive, and I will use Colab notebook, a free GPU which is being provided by Google. This is what I'm going to do here. So let me just rename it quickly. So I'll call it reverse HD, for example, reverse stable diffusion. This is my Colab notebook name. I'll just change the runtime. It's still connecting. I'll click on this runtime. I will click on change runtime type, and I will click GPU here, and I will just click on save, and it's connecting to this runtime currently. It says connecting, initializing Python 3 Google Compute Engine backend. It uses GCP in backend, so I'm doing that, and it will take, you can see it's connected. I can also mount to my drive. I don't know if this makes sense to mount this, but anyway, let me just mount it with my Google Drive, and this is what I'm going to use, guys. So the CLIP Interrogator tool that we are going to use, CLIP Interrogator has been developed with the help of OpenAI's CLIP and something called BLIP, which is by Salesforce. Now let me just write it, what we are going to do here, guys. So we are going to use this, excuse me, let me just make it up, reverse stable diffusion. So this reverse stable diffusion, in this one, what we are going to do, we are going to take help of OpenAI's CLIP, and a framework that has been developed by Salesforce. This is the underlying tech that we are going to use, by the way. So if I just click on this, the tool that we are going to use basically as a Python library is CLIP Interrogator. This is what we are going to do, guys, okay, in this tutorial. So now you see my runtime is connected. Okay, I am in this notebook. Now what I have to do, I have to install this pip install CLIP Interrogator. So I'll just do pip install CLIP Interrogator, and the version that I need is 0.6.0. Let's install this. It says invalid requirement. You can see it's installing it. Pip install CLIP Interrogator. And the dependencies are, if you want to run it in your local system, if you don't want to run it on Google Colab, where you can see PyTorch and Hugging Face, a lot of libraries are installed by default in Colab. You need transformers, you need torch, you need sentence piece to work with this library that I am using, CLIP Interrogator 0.6.0. and if you come down, okay, now we have installed it successfully. What we will do, let's import couple of libraries here. The first that we need Kilo, so I'll say import I should be capital IMGE. This is the first thing. Then I need the CLIP _interrogator. So from clip underscore interrogator import, we need two things. The first is config, and the second is the interrogator class. So I'm just going to you can see I have successfully imported. So these are the dependencies that we need, okay, to do the image to prompt. So we'll upload an image and input, and then we'll generate the prompt out of it. Okay, we'll see what kind of prompt that has been used, to generate that input image. This is what we are going to do now. So let's define a variable. Let me first upload this image. So what I'm going to do, I'm going to upload couple of images. The first image is this Mona Lisa. Let me also import this HD sample, and I'm going to upload this in this current runtime. You can also mount it as I have mounted it. You can just import it, load it from drive as well, your drive folder. But I just to explore this tool. So image.open. In image.open, I will pass this image. So the first is Mona Lisa dot png, and then I think it's already RGB, but you can also convert it to RGB. So you have to convert an image to RGB. Most of the time we generate image which are not RGB as well, so we can also do that. We can convert it to RGB. If you are also getting an error, you can also have a look at, maybe if when I was using this tool, when I was trying to integrate this with Gradio and Streamlit, I was getting error. Maybe you can use something called image to array as well, in that case, if you are getting any error while using this. Now what I will do, I'll just let me first show the image. So I'll just do image. It will show the image. So this is the image that I have loaded. Very beautiful image, right? Very beautiful image, generated image of Mona Lisa, by Stable Diffusion. So now what I'm going to do, I'm just going to call it clip interrogator, and I will just do interrogator. The class that we have, the class that we have imported. So one second, interrogator. This is my class interrogator. So in this, what I have to do, now I have to use that config. So I will use config, and in config method I will load this clip model. So my clip model, and I have to give a name. So it's called clip model name, and that model name you have to use a model which is again by the same OpenAI. It's a vision, it's a vision transformer model that I'm going to use. So it's called VITE, where I is small and L and the 14, and I'm going to do it OpenAI, where it will load from OpenAI. Let me just load this. It says loading caption model BLIP large. So we are loading the large model that you see, VITL. So vision transformer large. This can be basically the checkpoint version. Okay, I'm not sure about this number right now. So vision transformer large 14 from OpenAI. It's downloading all the model weights and the checkpoints here. It will be here in your local cache runtime. It will be cached here. So let it load. It will take little time. Now if I go back, here on this, you can see the comparison that has been done with clip vision transformer large model with Resonate 101, which is already a very large model, and they have compared that, and there's the benchmarking. You can see the increase in performances on multiple data set here, on the test data set. This is a very, very, very fundamental paper to read as well. I'll share this link in description. And you can see it's now loading the clip model VIT vision transformer large OpenAI, and it will load. So let me write the next set of code. So once you can see, you can successfully have loaded in 35 seconds, half a minute. Now what we'll do, now we'll just pass this image. Okay, so what I'm going to say result. So result equals ci dot, here I'm going to use this interrogate method. So ci dot interrogate, you can see this is a method that I am going to use, and in this I will pass my input image, the image that I have loaded of Mona Lisa, which I have stored in this image variable. So what I'm going to do, I'm going to just pass this image variable here, and let me just run this. and guys, it will take up to, from few seconds up to a minute, depending upon your memory and RAM, of course. And you have to run this on a GPU machine. If you are trying to run on a CPU machine, you might get, out of memory error. Okay, it will give you this memory out of index or something. And this is the reason I am using it. And you can just see it below. It's now almost 30 seconds, but it will perform the inference on the model that we have loaded on top, and then we can print the result to see what kind of result we are getting. Okay, you can see, but you can see it's loading it over here. You can also keep a check on this RAM. Here it says, you can see the RAM that has been utilized. I have very less RAM, okay, on this one, which makes sense. I'm using a free Colab, guys. It's a free free GPU given by Google Colab. Okay, I'm using it. I think they also provide 15 GB, if I'm not wrong, space as well. So it might take up to a minute or two. You can see it over here. So let me come back once this is done. Okay, I'll just pause the video here. So you can see the result has been successfully completed. The sale has been successful once we run. Now let's print this result and see what kind of response we are getting. Are we getting any prompt? And this is the result, guys. It says, image of a painting of a woman with a candle rendered on Unreal 3D engine. That's the engine, by the way. Painting of Mona Lisa. Now just see how superb is this, right? You have an input image and you are getting a prompt out of it, and this is so real, so accurate. You have a painting of Mona Lisa, you have this Unity render, Invisible Women by Pinturicchio, NVIDIA promotional image. This is an artist style, by the way. NVIDIA promotional image, Aquiline features, Da Vinci, again the artist, depth blur. So this is the prompt we are getting, guys. So this was an input image. In our case, this was a Mona Lisa image that I have generated using stable diffusion, with the help of ChatGPT prompts. And when I'm passing it to it, you can see the response that I'm getting. Okay, here on this one. Now it doesn't matter if you are just uploading a stable diffusion or a DALL-E or a Mid Journey. You just upload an AI generated image, because this can also help you to detect whether an image has been generated by an AI or not. This is very helpful for reverse engineering that process. Okay, if you want to reverse engineer that process, if you want to detect some AI generated images on internet or on your application or bot, some kind of content, you can also do that. Okay, it also helps you reproduce. Now you take this prompt, reproduce with some other images, right? And this is what this lot of tools does. You see, currently I am on this Prompt Hero, which provides you different kind of example or samples for prompt. Now what I will do, guys, let me just do one thing. Let me just try to change this image. As I said, I have changed it to hdsample.jpg, the other image. And by the way, this is a compute heavy model, guys. Okay, requires high computational power. You require a GPU to run this model. I don't know if you have a quantized model available. If you have any quantized model where people have quantized this, to different, float or something, that you can try it out and see if it works faster on a CPU machine. I haven't tried it yet. So what I will do now, I will just try to run this. So I don't know why I did this. Let me just run this once more. So let me just load the image. So I have loaded the image, and now I'm showing the image by printing this image. You can see this is my image. Now I'll just pass it again. I don't know if I need this to load. I don't need this. So I'll just do result ci.interrogate image. You can see it's performing the inference on it. So we are able to make the inference on that particular image. Let me just see my RAM. It should not exceed that. Okay, otherwise my session will crash on Colab. That's the problem of Colab, but there are workaround. You can also manage that, but I think this should work. Now let's see. But at least for Mona Lisa image, guys, it performed superbly, right? You can see there are a lot of applications that I can see now. You can create a Gradio or Streamlit application. You can create a Gradio application directly from this Google Colab and share with your friends and to your peer to evaluate this model, what kind of responses you are getting. The more you test, better you will know about this model, robustness and of course the accuracy as well. So but it's very real. It's not the way you say 100%, that will not be there, of course, but it works well. Now let's me print this result, and you can see, right, it says a close-up of a man with a beard and a jacket, and this fantastic, right? And art style Greg Rutkowski, made in 1800s, Discord profile picture. Wow, this is amazing. We have an artist name Edmund Blair and Charlie Bouter. We have nationalist. This is so good, guys. See this realistic masterpiece. Now let me just copy this, and let me open my, I don't know, maybe I'll open the sticky notes where I will just paste it. Okay, meanwhile it's getting ready, let me open a notepad. Okay, I don't want to wait for that long, so let me just paste it over here. See, this is my this one. Now let me just go back on this pictures. I have this st image. Now you can see this is the image that I uploaded as an input, and now we have got this prompt. So what we are doing here, guys, we have done a reverse engineering of prompt to image or text to image. Now what we are doing, we are having image to prompt, generated AI image or generated image with the help of AI. This is the right statement, by the way. So generated image with the help of AI to prompt. So we have done this prompt reverse engineering of this entire process, and this is extremely powerful. This has a lot of use cases, as I discussed earlier in the beginning of the video. You can use this, you can build an application or build an API that will take an image as an input and it will generate a prompt. Now you can use this to detect AI generated images. There are a lot of applications already or startups already working on those areas. They have built a platform, they have built a software as a service application where you upload an image and they will give you this output, whether they are being generated by Stable Diffusion, Midjourney, DALI, what kind of prompt that has been used to generate that image. There have been applications in industry, in community. You can also do the same. You can use this to reproduce, you can use this to detect an AI generated image, explicit content, any kind of content, right? You can do this keyword matching or similarity, try to find out, it's extremely powerful. Now it's up to you how you extend this further, but I just wanted to show this. Now let me also bring this notebook. I'll share this notebook in the description. It will be available on AI Anytime GitHub repository. Maybe in the coming video I will create a Gradio application or Streamlit application. I can deploy this. I will try to also containerize this. Now it totally depends on you. You can create an API out of it, go and host it or deploy it on Rapid API, and you can also make money out of it. Okay, but don't forget to give credits to the people or the community who has built this fantastic tool called BLIP Interrogator. You can find it out on PyP or GitHub. There will be repositories, and this is what we did today in this video, guys. We have reverse engineered the Stable Diffusion. Okay, so we have done image to prompt rather than prompt to images. Okay, and this is very interesting. I wanted to work in these areas, and very happy with the response we are getting, very happy with the performance of the CLIP and BLIP model. So CLIP by OpenAI and BLIP by Salesforce is working extremely well when we combined this with help of this tool that they have built, CLIP Interrogator, which is available on PyP and GitHub, by the way. Please give them credit and please cite them as well. Kudos to them. So this is this is extremely well, a lot of use cases there. Now please let me know what you do with this code base, or if you extend this tool further, please let me know. Please share your thoughts and feedbacks with me. Okay, that's all for this video, guys. Okay, I hope you are liking the content. If you like my content, please share the channel with your friends and to your peer. If you haven't subscribed yet, do subscribe the channel. Okay, that's all. See you in the next video, guys. Thank you.